Hello and welcome to the world's first great ocean liner, the SS Great Britain. My name's Nicola Grahamslaw and I'm the conservation engineer for the ship. I'm going to take you on an exclusive behind the scenes tour to have a look at some of the engineering behind both the design and the conservation of the ship. We'll talk about the technology that's being used to look after the iron, and we'll talk about how we're using the data that we're collecting as we work towards reducing our carbon footprint. We'll also talk about how sharing the research that we're doing here on site can help to increase the size of the impact of that work. But first, let's go under the glass sea to find out what made this ship so remarkable. The SS Great Britain was the first ocean-going ship to be made from metal rather than wood, and she was the first ocean-going ship to be driven by a screw propeller instead of paddle wheels. Both of these technologies are still in use today, which means that she was the prototype for all modern shipping. She was designed by Isambard Kingdom Brunel and was constructed right here in this very dry dock between 1839 and 1843. The work that Brunel did on the screw propeller was truly revolutionary. In fact, the report that he wrote, persuading the shareholders of the Great Western Steamship Company to consider screw propulsion for this ship, has recently been recognised by UNESCO as being pivotal for shaping the modern world. 175 years ago this year, the SS Great Britain arrived into New York City for the very first time. Over 20,000 people arrived and paid 25 cents to board the ship and have a look around. She'd already become a tourist attraction. Let's go and have a closer look at the material she was built from. We've come to the bow of the ship to take a closer look at the material that she was built from. The SS Great Britain is built from wrought iron, which allowed the ship to be bigger, stronger and longer lasting than had ever been possible before. Early on in her career, she was run aground in Northern Ireland, and in fact this ordeal bankrupted the Great Western Steamship Company. However, the ship survived and went on to sail more than 1 million nautical miles before being abandoned in the Falkland Islands. And then it was the longevity of this material which allowed her to survive, be salvaged, refloated and towed the 8,000 miles back to Bristol in 1970. And we've just celebrated the 50th anniversary of that salvage. And because the iron is such an important part of the ship's story, our conservation strategy is centred around preserving that original material. And the Trust did some research together with Cardiff University to determine how dry the air in this dry dock needed to be. And the result was it needed to be 20% relative humidity. That's as dry as the Arizona desert, compared to the air outside, which in Bristol can often be in the 80s or even the 90% relative humidity. The dry air is delivered to the ship using two big dehumidifiers, and the air comes out through these vents here. By creating a protective curtain of air over the surface of the ship, we can keep the part right next to the ship at 20% relative humidity. And by limiting mixing between the curtain of air here and the air elsewhere in the dry dock, we can reduce the energy required by the system as a whole. And that also means it doesn't matter too much that the walls of the dry dock are porous, which means they actually let through a little bit of water. But as long as we have this protective curtain of dry air over the surface of the ship, we can slow down that corrosion reaction. Engineers used computer modelling to design this system, and along with the dried air curtain, the model also showed that the layer of water on top of the glass plate, as well as creating a fantastic visual effect, also adds an insulating layer, and this gives us a further energy saving. There are two dehumidifiers, one in the dry dock and one on board the ship. So let's put on our hard hats and go and have a look closer at the one on the ship. Now, if you visited the ship, you will have seen the dining saloon and you will have seen the cabins, which we've reconstructed to look exactly how they would have been in the 1840s and the 1850s. But you won't have seen the hidden deck where the dehumidifier is. I'm about to take you to have a closer look, so let's grab our hard hats. So now we're making our way through the hidden deck on board the SS Great Britain. Right here we're underneath the replica engine, which you might have seen moving if you visited the ship. But it has to be switched off so that we can come through underneath it. As we've made our way through the hidden deck, we can see really clearly the condition of the iron hull and the iron girders which form the structure of the ship. But what we're really here to look at is this, the second dehumidifier on board the ship. Now, The dehumidifier dries the air by forcing it through a desiccant, which is a type of material which absorbs moisture. The desiccant can then be reconditioned using heat, and that then collects up the moisture and sends it back out to the air outside. And this can happen as a continuous process, and by doing this, it means we can use the same desiccant material in this dehumidifier for up to 10 years. To help us calculate how much heat to recondition the desiccant, we use these sensors. Now these are attached to all over the ship next to the metal, and that tells us exactly what the relative humidity is at the surface of the metal. And we can use this information to calculate how much heat we need to use to recondition the desiccant. We also monitor the temperature and the humidity of the air as it travels through each part of the dehumidifier. All of this information is processed via these controllers, which send information to our network. The dehumidifier components like the gas burners, the fans and the heat recovery pumps are also connected here, meaning that I can monitor and adjust the software code which controls each component. And I can even log in remotely to look at the data and control the dehumidifiers from home, which has also helped us to conserve the ship during lockdown. The heating, the dehumidifiers and the ventilation in our archives, museums, offices and visitor centre are all controlled and monitored by this same system. So we're nearly at the end of our behind the scenes tour, and here we are back in the dry dock next to the other dehumidifier. There's one on board the ship and one in the dry dock down here. And we're using the sensors to monitor the conditions on both sides of the original iron. Recently, we installed an upgrade to the control system, and alongside that we purchased some new sensors. Now these are really useful because they are more accurate and they also have a more reliable communication than the previous generation of sensors. And that allows us to see the data in more locations around the ship, so we can keep track of where that air is going and how it's doing with drying the ship. And it also allows us to collect more accurate data. And we can use that to help to fine-tune the system to optimise those airflows and make sure that we're protecting every part of the ship while also minimising our energy consumption. The SS Great Britain Trust have declared a climate emergency, and while on site we're already taking steps like generating solar power and reducing the amount of waste we send to landfill, this technology will also be really useful when it comes to helping to minimise our carbon footprint. It will also help us to collect the data to determine whether we can replace some parts of the system with completely renewable powered solutions. By sharing our research and our experience with our wider networks, we can help other maritime museums and other conservation professionals with their conservation as well. So that work that we're doing can have a wider impact, and we can help each other out to work on the climate emergency together. My own experience in engineering before working at the SS Great Britain was in nuclear power, where I worked with a team of engineers analysing cooling flows through nuclear reactors and writing control algorithms to control the stations. So you can see how that experience would be directly relevant to the work we're doing here on the SS Great Britain. So engineering has always been about problem solving, whether that's Isambard Kingdom Brunel and the Victorian engineers driving forward innovation for transportation and communication, or whether that's modern day engineers tackling big problems like climate change. So this brings us to the end of our behind the scenes tour. Thank you very much for joining us. There are lots of ways that you can get involved if you want to find out even more about the work that we're doing here. You can come and visit the ship and see the dehumidifiers in action. You can follow us on social media, where we'll be sharing more detailed content via our website. Or you might even consider getting involved with the SS Great Britain crew as a volunteer. Thank you.